Hi everyone. Today we're going to be talking about power. So the definition of power is the time rate at which work is done by a force. So if we look at the power equation, we get power is equal to work divided by time. So this is going to be the rate at which work is done on an object. And as we know, we have like an average velocity equation and an instantaneous velocity equation. We have the same thing with power. Average power is work over time, and then instantaneous power will be the instantaneous time rate of doing work. So what we get here is power is equal to dW over dt. Now, from this, we can see that if we have a work function as that work done on the object changes with time, then what we can do is if we want to get the instantaneous power at say t equals 3 seconds during that work interval, we can then take the derivative of that function and evaluate the result at t equals 3 seconds to get the power at that time. Also, if we have a graph of work as it changes with time, then we can get the slope of that graph at any point in order to find that instantaneous power. So you can see power is the derivative of the work function as it changes with time. Now, we also know that work is equal to a change in energy. So when a work is done on an object, that object will have a change in energy. And because of that, power will be the rate at which energy is transferred by a force from one type to another, from an object or to an object. So we can get an average power equation that looks like this as well. So power is equal to the change in energy over time. And then of course, instantaneous power will be this equation right here. So just like I was talking about with a graph of work as it changes with time, if we have a graph of energy as it changes with time, the power will be the slope of that plot at any given time. And then of course, the power equation will be the derivative of the energy function as it changes with time. Now, the unit for power is watts, and you've probably heard of this unit before because a lot of light bulbs are rated in watts. And this unit is named after James Watt. Now, in Great Britain, they use foot-pound per second, so that might also seem kind of familiar. And horsepower is probably a unit that you've learned before. So 1 watt is just 1 joule per second if you think about the power equation. Work over time, energy over time. This is joules over seconds, and that is 0.738 foot-pounds per second. And then 1 horsepower is 550 foot-pounds per second, and also equal to 746 watts. The unit conversion that we'll use the most here is the 1 horsepower equals 746 watts. And really, you probably won't see this on the AP test, but it's helpful to know that if we want to convert to horsepower, we use that conversion that's equal to 746 watts. Now, kilowatt hours, it might be something that you've heard of before as well. This is actually a unit of work. So work can be expressed as power multiplied by time if you look at that power equation. And so we sometimes use that unit kilowatt hour because, of course, watts is a unit for power, and then power times time will be our work. So 1 kilowatt hour is equal to 3.6 times 10 to the 6 joules, or 3.6 megajoules. Now we can get an alternate power equation. Now, the way that we do this is we're going to start with an equation. We know that power is equal to work over time. So work, we know, is force times displacement times the cosine of theta. Now here we're looking at like an instantaneous power. So displacement, we have an instantaneous time rate of displacement, dx over dt. And of course, that looks really familiar, right? We know that that is going to be our instantaneous velocity. So what we can get here is that power is equal to force times velocity times the cosine of theta. So since it's cosine of theta, it is still a dot product, and you can actually see power is equal to F dot V on your equation sheet for the AP test as well. So like I said, we can write it as a dot product, P equals F dot F dot V, and this is on your equation sheet on the AP test. So this is another equation that we can use when we are solving for power. So if they're giving you a velocity, you're usually going to use this equation when solving for power.